Hello everyone. In this video, I'm going to discuss about SLR parsing. It means a simple LR parsing. It is a type of bottom-up parsing used in compiler design, used to analyze and process programming languages. It is the most efficient and automated approach compared to the manual parsing technique. These are the steps involved in the SLR parsing. First, we need to construct the augmented grammar. In the augmented grammar, we have to introduce one new start symbol. And we have to find a closure function, goto function. After finding the goto function, we have to find the follow of non-terminals. Next, we need to construct the parsing table. After completing parsing table constructions, we have to check whether the given input string is possible to create using the given grammar. So these are the steps involved in the SLR parsing. We'll take one example and we can solve it how it is going to be. Let us take this example for the SLR parsing. In this example, we have three production rule. One is S tends to double A. Second rule is A tends to small a capital A. Third rule is A tends to B. And we have one more string AB. We need to check whether the string is possible to generate using this grammar. Creating the augmented grammar is the first step in the SLR parsing. It's very simple. We need to introduce a new start symbol, which is denoted as a S dash. So S dash tends to yes. So the remaining rules will be taken from the given problem. So already we have a three production rules. Additionally, we have to include one more production rule. So these four rules is called it as an augmented grammar. So this is the augmented grammar in the first step what we found. So for this augmented grammar, I am assigning the number for each and every rule. So the first rule S dash tends to S is denoted as a 0. The second rule is denoted as a 1. Third rule is denoted as a 2. As well, fourth rule is 3. So after this number assigning, we need to find the closure function. So closure function is a very simple. We need to introduce the dot value in each and every production. So the first production is S dash tends to S. We need to convert as a dot S in the right hand side. For the second rule, we introduce before the first A, we are introducing dot symbol. As well, small a before we are using the dot symbol. In the fourth rule, we introduce a dot before B. So, all the production rule in the right hand side, first value must be a dot symbol. So, this is called as a closure function. So, this is denoted as a I0. Next step is applying the goto function. We need to apply the goto function for the variables which is present after the dot symbol. We need to find the goto function for capital S, first capital A in the second rule, for small a and small b. So for I naught, we need to find the for goto function. So goto function is very simple. When you apply the goto function, the dot will be moved one step right. So if you apply the goto function for this capital S, you will be getting this as a result. So this dot symbol is moved one step right. So in the right hand side, you got the result as S dot. Okay, so this is denoted as a new state I1. Okay, so this goto functions will be generally represented as a goto I0 comma S. It means this is the current state, and for S we are going to apply the goto symbol. So you will be getting this as a result. So if you apply the goto function for capital A, what will happen? This dot will be moved to one step right. You will get the result as like this. So for the second rule, dot is moved one step right. So you will get the output as a dot A. Okay. So in the result, look at, we have one capital A after the dot symbol. So it means you need to check in the initial state any production rule is there for this capital A. Yes, we have a two production rule for this capital A. What is it? A tends to dot A tends to dot B. These two production rules must be added in this result state. Okay, got it? So this is the output for the goto of A. And then next we need to find the goto function for small a. So if you move this dot to one side, right, so you will get the result as a small a dot capital A. After this dot you have a capital A. What you have to do? You need to check in the current state any production rule we have for this capital A. Yes, we have a two productions rules. One is A tends to dot AA, another one is A tends to dot B. Those two productions rules must be added in this result state. This is denoted as I3. Now we need to find the goto function for small b. Okay, so the small b, it's going to be this as a result. The dot is moved one step right, so A tends to B dot. So this state is represented as a I4. Okay, so if you take this I1 and I4, we don't have any terminal after dot symbol. So you no need to find any new state for I1 as well as I4. But if you see this I2 and I3, we have variables after dot symbol. So what we need to do first with I2, we need to find the goto symbol, goto function for A, and we need to find the goto function for small a, and we need to find the goto function for small b as well. So first I am going to apply the next step. So if you apply the goto function for capital A, this dot will move one step right side. So you will get the result as S tends to capital A dot. For after this dot, you don't have any variable at all. So you leave it as it is. Okay. And then you need to find the goto function for small a. So you will get the result as the same. Why? Because this dot is moved one step right, you will get this as a result. And after this dot, what you have? You have one more capital letter. If you have a capital letter, what you need to do? You need to check the current state. If you have a production rule for the non-terminals, you need to include those two production rule as well. So you will be getting this is as a result. These result already we have in I3. So when you apply the goto function from I to A, you will get this as a result. So the direction is given for I3. If you apply the goto function for B, you will get A tends to B dot. That output is also available in I4. So that when you apply the B, you will get the result is A tends to BA. Now we completed the I2. So what we need to do? We need to proceed the I3. So if you take the I3, in the I3, first rule what you have? A dot A. So this dot will be moved to one step right. So you will get this result. A capital A dot. After this dot, you don't have any other non-terminal. So leave it as it is. Okay. So next, if you apply if you take the second rule, you have a dot A, small a and capital A. Right. So if you apply the goto function for the second rule, you will get this as a result. That is A dot A, and then since you have a A after a dot symbol, you will get these two production rules. So what you have to do? You have to represent the self loop. For the second production, you will get the same result. So I have mentioned this is a self loop. So for the third production rule, dot B, if you apply goto function, it become a B dot. Okay, so it is already in the I4. So I have given the direction to the I4. Okay, so if you look at this I5, I6, which is created in new state, After the dot symbol, you don't have any non-terminal or a terminal in I5 as well as I6. So we have to stop the go to functions in this stage. Okay. You need to find the parsing table. So how to represent this parsing table? We have a action table and we have a go to table. So the action table we have to include A is so in this grammar what are the terminal symbols we have? We have a A and then B, and we included that A as well as the B, and we need to include dollar symbol in the action table. Okay, and what are the terminal symbol in this grammar? We have a capital A and then capital A. Sorry, one is yes. So yes and then A is included as a non-terminal in the go to table. Okay, fine. So next we need to fill this table content. So the table content is going to be here. So first I am going to fill this 0 comma A. It means this is representing this state. So state is I0, and what is the input? Input is A. So where it is goes? It is goes to I3. So it means that in the current state is 0, and then this input is A, I have to go for I3. So this I3 is represented as a S3. It means from one state to its another state it is shifting. Okay, so that it must be represented as a yes shifting. Where it is going to shift? I3. So it must be represented as a 3. And if you take a B from 0 and from the I0, the input is a B, it is goes to I4. It means you have to represent it as a S4. Okay, so if it is a, it is goes to I2. In the go to function, you should not represent any shift yes or a reduce yes. Just you need to denote the number. So what is the number in the state 2? 2 is the state. So you have to represent just 2. And if the input is yes, where it is goes to I1. I1 means what you have to do? Just a number. 1 you must write. Okay, so this is the way you have to fill. And if you take the second exam, second one, there is from one state one, you don't have a B anything, you have a final state. Okay, so the final state is yes tends to yes. So this is the rule. Okay, so it means that it is the predictions rule we have here. Yes tends to yes, right? So this is representing the follow of yes. So what is the follow of yes? Dollar symbol. So it must be a accept. So 1 and dollar, it must be the accept. In all the protection rules, mostly the 1 and dollar will be the accept. Okay, and the next we need to go for the second. I2. I2, if the input is A, where it is goes I3. So in A, you have to mention as a 5. And if it is A, where it is goes to I3. It means that you should represent S3. If it is B, where it is goes to I4. You have to represent it as a S3. Okay, you have to represent it as a S4. Okay, and then go to the I3. So if you consider this I3, so I3 means A means A, if it is an input, small a, it is goes to the same state. So S3. And if the input is a B, it is goes to I4. So it is going to be a S4. Okay. And then if the input is A, it is goes to I6. So you have to represent here 6. So this is the way you have to fill. And I completed this I2, I3, I1. So if you see the remaining production routes over here is I5, I4, I6. In the I4, so since you don't have any non-terminal after this dot, you don't have any terminal or non-terminal, it must be reduce function. So this I4, that is a 4, 5, 6 is going to be the reduce function. Okay, so if you are in I4, okay, you don't have any state transition, what you have to do from I4, what is the production rule we have? We have A tends to B. So A tends to B means, so what is the number we have? We have a 3. So you need to represent R3 in the box. Okay, once again I'll tell you this. If you take this I4, that is representing the state number, and what is the production rule you have? A tends to B. In this rule production, what is the number assigned for the A tends to B? It is 3. So since it is the reduce process, you must represent it as a R3. So in the R3, whether you have to include in A, B, where you have to apply. So to find that, we have to find the this A rule, right? So follow of A. What are the follow of A? A, small b, dollar. So in A, B and dollar, you must include R3. Okay, so you go to the I5. I5, what is the rule? S tends to AA. So this is the production rule. What is the number for this production rule? 1. Okay, what is the left side value? Yes. So follow of yes is what? A dollar. So in dollar only you have to apply the R1. Okay, and then take the sixth. So this is the sixth state. In the sixth state, what is the protection rule? We have A tends to small a, capital A. So this is the second rule. Okay. So what is the left side? We have a A. So what is the follow of A? A, B, dollar. So in sixth A, B, dollar, you have to represent R2, R2, R. So this is the parsing table content. Okay. So this is the way you have to find the parsing table. So once if you find this parsing table, you have to check the input AB is possible to generate using the grammar which is given here. Okay. So for that we need to use the stack implementation. So in the stack implementations, the table contains three columns. One is stack and another one is the input string and the action. So initial stack will be 0. The input string is AB and we need to find the action. So initially 0 and A. So 0 and A, what we have? Shift 3. So you have to write a shift 3. So once if you write the shift 3, you have to fill the second row. Second row must be 0 and this A will be shifted to stack and the action number shift 3. 3 will be shifted to stack. So you will get 0 A3. So in the input string you have a BAB dollar. And if you compare this the top of the stack 3 and then input string B. So 3 and then B. What you have? S4. So shift 4. So this B will be shifted here and 4 will be shifted to the stack. So since you shifted 4, you will get the result as 0 A3 B4. Now, the input string remaining element AB dollar. Okay, just compare this 4 and A. 4 and A is a reduce 3. So, you will get a reduce 3. What is the third rule in this production rule? A tends to B. So, A tends to B. In the right hand side, if you have one element, in the next step, you have to replace two element from the stack. Okay, so what is the two element in the top of the stack? B4. So instead of B4, you have to replace A. So your output is going to be 0, A3. Instead of B4, the A is replaced. Okay, so after A, you must have the uh, numeric value. So we are going to compare this 3 and A. So 3 and then A, what you have is 6. So 6 will be added in the stack. Now top of the stack is a 6. Input string is A. So compare 6 and A. 6 and A is reduced 2. So reduce 2 means a second rule. What is the second rule? A tends to A, capital A. So instead of this AA, you have to replace capital A. Since it have two element in the right hand side, from the stack you have to replace four element. What are the four top four? 6A, 3A. So the four element will be replaced by this A. After these A, you have to include one element. How to find? Before A, what you have? 0. 0 A. 0 and then A, what you have? A 2. So 2 will be replaced here. In this input string, you have AB dollar. So compare 2 and A. 2 and A shift 3. So shift 3. Shift the A to the stack. Shift 3 to the stack. So this will be the output in the stack. And you have the remaining element in the input string. So compare this 3 and B. 3 and then B. What you have? S4. So S4 means a shift 4. So this B will be shifted and this 4 will be shifted. So this is the stack content. Okay. In the input string only you have the dollar symbol. So compare this 4 and dollar. So 4 and the dollar, what you have? R3. It means reduce 3. What is the third rule? A tends to B. So A tends to B. Since it have only one element, the first two top of the stack will be replaced. B4 will be replaced with A. So after A, what element we need to have? So check with previous element of A. What is that? 3. 3A means 3. A means 6. So 6 will be added in the top of the stack. Now check the 6 and dollar. 6 and dollar is reduced to. So reduced to, the second rule is A tends to small a capital A. Since we have a 2 element in the right hand side, 4 element must be replaced in the top of the stack. What are the 4 element from the right side? 6A, 3A. So that will be replaced. After 2 you will be replacing with A. So what is the next number we need to have? So compare the A and previous value of A. What is it? 2 and then A. So 2A it is going to be 5. So 5 is added in the stack. Okay, so 5 and dollar, what is it? 5 and dollar reduce 1. Reduce 1 means S tends to AA. So that is going to be replaced. Since it is having 2 element, 4 element from the stack will be replaced. So this 5A, 2A will be replaced with the S. Okay, so you have a 0 S. So 0 S is what? 1. So add 1. So what is the last element here? 1. The 1 is compared with the dollar. So 1 and dollar it is going to be accept. So the given string can be accepted. So this given string can be generated using this production rule. So this is the way you have to process the production rule and check the input string in using the SLR parsing. Thank you.